Hello guys, welcome to Fluid Mechanics. Before us we've got a stream function and we are requested to find the velocity potential and the velocity magnitude at 0.2 meters and 4 meters, right? So in order for us to do that, we need to know the expression for the x component of velocity, which is the partial derivative of the velocity potential in terms of x, which is also equals to the partial derivative of the stream function in terms of y. So we're going to use these expressions in order for us to find the velocity potential. Okay, so let's just continue. Then we've got the partial derivative here. This equals to the partial derivative in terms of y of the stream function, which is 3x minus 2y minus 2y. Okay, fine. So this side remains the same. Then if we find the derivative here in terms of y, we are going to get negative 2, you know. So at this point, we need to find the stream function. So we are going to work it out in this manner in terms of x over there. So in order for us to find the stream function, we need to integrate, you know. And then this is going to result into the stream function equaling negative 2x, right? We would normally say plus c, but this is a partial. We had partial derivatives, you know. So instead of plus c, we're going to have a function in terms of y, you know. Okay, and obviously, how are we going to find this function is we are going to include also the y component of velocity in here, right? And the y component of velocity is given by this expression. So it's minus the partial derivative of the stream function in terms of x. So even here we apply the same rule, you know. So partial derivative of the velocity potential in terms of y equals to minus the partial derivative in terms of x of the stream function, which is 3x minus 2y. Okay, so on the left hand side we've got this, and on the right hand side so it's minus. If we differentiate this in terms of x, we're going to get 3 over here, you know. Okay, so what do we have here? We've got we need to find the expression for the velocity potential, right? So we take it further in this manner, and then in order for us to find the velocity potential, we integrate. Then this guy equals to, so we're going to integrate in terms of y. This is going to be minus 3y plus a function in terms of x, you know. So finally, our velocity potential equals to, let's check, minus 2x minus 3y. So we have found our velocity potential over here. And so now we need to find the magnitude of velocity. We need to find the magnitude of velocity, which is this over here. Obviously, to find this, we are going to use its different components over here. Okay, so your v will be the x component squared plus the y component squared. So let us check. So the x component is this over here. This is the x component, and even if we're going to substitute this point, we're still going to have negative 2. So that is the x component, negative 2 all squared, plus what about the y component? The y component is this over here. Even if we're going to substitute 4 over here, or 2 and 4, we're still going to get negative 3. Right? All squared. Then what does this equals to? This is negative 2 squared. That is 4 plus negative 3 squared. That is 9. So this equals to the square root of 13 meters per second. Alright guys, do stay blessed and enjoy the rest of your day.